Hello and welcome to the introduction to zOS datasets. My name is Philipp Brune of the Neu-Ulm University of Applied Sciences. The file system of zOS is special compared to file systems of operating systems that are more common to us usually, like the file systems of Linux or Windows operating systems or Unix operating systems, which are all hierarchical file systems, meaning they have folders or directories containing files and other folders and directories containing files, so they have a hierarchy. The file system of zOS is completely flat. So basically it just consists of files, and these files are called datasets in the language or the terminology of the mainframe of zOS. And also these datasets, they cannot just be used. If you save, for example, a file on Windows or on Linux, the file is just created if it has been saved before. This is not possible on the zOS file system. Every file on the file system has to be allocated before it can be used the first time. And this step of allocation means allocating memory on disk for this file. Every file gets a size, that is an initial size that is associated with it during the allocation, which is the start size, and sometimes called as the primary extent, which is the size in the beginning. And then during the allocation, a secondary extent is defined by which the file can grow up to 15 times. So in total, it's the primary extent plus maximum 15 times the secondary extent. If this is used completely, the file has to be, or you have to create a new file and copy the content in the new file. So files cannot grow beyond this boundary. And this is very typical for the mainframe, but very different from what we are used to in other operating systems that for many of us are more common at home, for example. So these data sets, as they are called, are allocated first, and afterwards they may be used. And this allocation takes place on a disk originally. Today, of course, the I/O system of the modern mainframes is completely virtualized. We have storage systems, so we are not really allocating files on physical disks anymore. But logically, still this concept is there. So in principle, a file is allocated on a disk, and this is called a volume in the mainframe terminology. And originally this volume had to be indicated always. When you wanted to open the file, you had to say, oh, this is the volume, this is the file. But then later on, the so-called catalogs were added. And if a file is cataloged, meaning there's an entry in a central repository or list where for every file the volume is cataloged, then when you want to open it, the system looks in this catalog and takes the volume out of there. So nowadays, if the file is cataloged, it's possible to access the files only by the file name or the dataset name. And the second thing is that the datasets have typically a record structure. So they consist of records of a fixed length, and these records are put together in blocks, which correspond to read-write operations that can be read or written in one step. And this record length also has to be specified when the file is allocated. And every record has the same length then. So we have this strictly regulated structure of these datasets. And the names of the datasets are basically just text, or just strings that have some concept to give them a structure and organization, since we do not have directories or things like that. And these are the so-called qualifiers. So a dataset name is a string with maximum 44 characters. It can be shorter, but maximum 44 characters. And it consists of so-called qualifiers, and these qualifiers are separated by dots. You can compare that maybe to the names of in the internet, the host names, where you have dots and domains and so on. So in this sense, we have qualifiers, and the qualifiers are separated by dots. The full name is 44 characters, and in this example, it's split up into 5 identical parts of identical length. But it doesn't have to be 5. It can be also a different number, and the number of dots can also be different. So it's basically that you have, and it can be shorter, of course. There don't have to be so many dots or qualifiers. Typically, the first qualifier, the so-called top-level qualifier, is used for the user ID for normal user data, and for the system files or system data sets, there are some reserved names, and these are used then also to control access rights based on sort of names starting with a certain qualifier, for example. Okay, so this is the basic structure of the file system of zOS, managing data sets. And beside these flat files, there are also so-called partitioned data sets, which are more or less the only type of structure that the file system has. And this will be explained on the next slide. Beside the normal flat data set, which is a simple file that you could read and process sequentially or in arbitrary order, there is one type of special files that at least is similar to or has some resemblance to what we might call a directory, but it's much simpler, and it also does not provide a recursive hierarchical tree-like structure. And this is called the PDS. So there are some data sets that are so-called PDS, partitioned data sets. And later on there was an extended format called ePDS, which was added, but it's very similar regarding the use. And these two type of files can be understood as a kind of a library. So basically these PDS are just data sets, but they have an internal structure that consists of a directory in the beginning. So the first records, the first blocks of the PDS are containing the directory. And the directory basically is a list of names, maximum 8 characters. And these names refer to parts of the remaining PDS. So they can have an address that points to, for example, starting point of what we call a member. So these names are member names. A member name is at maximum 8 characters. And it refers to a part of the PDS after the directory header. And this allows to store information under a name. So it is a sort of a collection of things. You can think of it as a very simple one-layer hierarchy in a way. Okay. The members are addressed by specifying this member name after the file name of the whole data set in brackets, in round brackets, as you can see it here. And the members, of course, are part of one data set, so they all have to have the same block and record size. So you cannot mix up things there. It's only because it's one data set, it always has the same record size, for example. And when you allocate a PDS, you need to specify how big your directory is, because the directory header has to have a fixed size, so the system knows when the first member starts. And this has to be specified during allocation, additionally to the information that needs to be specified for an ordinary data set, for example. And the last thing that's sort of a historic legacy, but also an important concept that you need to know, especially when you read, for example, job codes, program codes that have been written a long time ago, is the structure of a hard disk, because it is used to determine the sizes of the, for example, the primary extent of a data set and secondary extent. So these are the so-called space units. When you allocate a file or data set, you need to specify how big it is at minimum and at maximum. And these sizes, of course, today could be specified in kilobytes, megabytes, units that we are used to. But in the past, it was the case that these units were always specified in units that refer to the structure of a hard disk. A hard disk in the mainframe environment is called a DASD, direct access storage device. So this is basically a hard disk. And the disk space that is specified in units referring to the physical structure of the hard disk. So a hard disk up to today consists of a number of rotating ferro-oxide disks that contain the information stored in a magnetic way. And there's a set of read-write heads that are moving in and out from the center to the border of the disk. And these read-write heads, they fly on top of the rotating disk on a very, very thin layer of air and read and write the information in a magnetic way. And so this is the fundamental structure. And this used to be the case also in earlier times. And because the read and write heads are mounted on a sort of a comb that is, like shown here, moves in and out, always, all heads move in and out in the same way, you could read and write simultaneously a radial circle that is always stacked on top of each other, like it is shown here. And this is called a cylinder. So one radial circle of information is called a track. So every disk has a track, and all tracks that are directly on top of each other are called a cylinder. And these are the units that are used for storing and specifying the volume amount. Because in the past there used to be an IBM hard disk device called a DESD called 3390. And this is sort of the original reference nowadays. So in this original device, one track had 56 kilobytes, and one cylinder was 15 tracks, so 15 disks on top of each other. And this is sort of the reference frame for specifying the disk sizes until today. So we can specify disk space in terms of cylinders or tracks, referring, for example, to this original IBM hard disk. And this is frequently done in jobs, and it used to be done, and it's still done today. So it's an important concept that one should understand when you especially work with sort of code that has been written before. And of course, in modern systems, we do not even have rotating disks. It could be solid state disks, for example, in the storage system. So everything is virtual today. So the modern mainframe has a complete storage virtualization layer, which is called DFSMS, which is a component that automatically, for example, handles where files are stored. It moves out files that are not frequently used, for example, from disk to tape or to other media. So in a transparent way, so the user does not see that, and if he once later accesses the file, it's automatically recovered from tape, for example. So these are nice features which allow a transparent storage hierarchy depending on the frequency of use of data sets, and of course all these cylinders and space settings are sort of virtual. There is no real 3390 disk anymore, but they are still used to specify the number of bytes. Of course, alternatively, we could use kilobytes, megabytes, gigabytes as well. So this was a short overview on the very specific features, and understanding the file system of zOS is crucial and fundamental for understanding the way how, for example, jobs are written and files interact with do I/O operations, COBOL programs do I/O operations, and so on, because it's the underlying thing is how the data is stored. So it's necessary to get a fundamental understanding of that. Thank you very much.